All right. Hello, Discrete Math. Um, just wanted to share with you guys, we are starting chapter one. We kind of started in the middle of the book. If you recall, we started with chapter five, and then we're skipping over kind of the end of the book, especially for the students that were in stats first semester with me. Chapters 14 and on are more of the stats kind of stuff that we've already talked about. So we're going to kind of skip over those to get to what I think is more the fun stuff. In fact, chapter one, I think, is one of the most interesting chapters in the entire book, which is the mathematics of election. So in this first section, we're just going to be talking about what are some of the basic elements of an election. So first off, basic elements that you're going to have. Element number one is the candidates. Element number two is the voters. Element number three is the ballots. Now with ballots, there's a few different ways you can do that. Single choice, where you just pick the favorite one. There's also preference ballots where you rank the candidates. So this is your first choice, second choice, third choice, so on. And then there's what's called a truncated preference ballot, which is where you rank a specific number of candidates. So pick your top two or pick your top three and so on. So your elements, the outcome. There's a few different ways you can determine the outcome. One of which is you can have it be a winner only. The second one is a partial outranking, where you kind of rank here's the top three people out of our election, and then full ranking is where you list off kind of everyone's choice based on all of the data. So some paradoxes of democracy, especially we'll talk about kind of how the United States election system is set up and why it may not be the best. But the paradox of democracy is that the more opportunities that we have to vote, it seems like the less we appreciate it and the less we understand the meaning of voting. For instance, why should we vote in the first place? Does our vote really count? In a lot of places, especially with our electoral college, it seems like it really doesn't. And then how does it count? And so these will be some of the questions that we are kind of posing and asking as we work through this chapter. So voting theory is really what it boils down to. That's kind of what we're going to be talking about as far as the mathematics of voting. The first half is the voting part, where people vote and cast their ballots. The second half is the counting part, where we decide who is the winner. And then at the end of this chapter, we'll talk about what's called Arrow's impossibility theorem, which basically says that the method for determining election results is democratic and always fair is a mathematical impossibility. So there really is no true bona fide way of having a fair and democratic election, which is kind of disappointing. So to set up this chapter, really, we're going to be talking about the math club election. So I am going to take the time to read through this. There's a lot of information on this slide, but we're going to be talking about this election for many of our future videos. So I want to make sure that you understand kind of what's going on. So the Math Appreciation Society, MAS, is a student organization that's dedicated to an unsung but worthy cause that of fostering the enjoyment and appreciation of mathematics among college students. The Tasmania State University chapter of MAS is holding its annual election for president. There are 4 candidates running for president: Alicia, Boris, Carmen, and Dave, which conveniently are A, B, C, and D for short. Each of the 37 members of the club votes by means of a ballot where they indicate their first, second, third, and fourth choice. The 37 ballots submitted are shown on the next slide, and once the ballots are in, it's decision time. Who are we going to pick as the winner? So here are all 37 of those ballots that have been cast. So notice that these are all preference ballots, preference schedules, where we've got A, B, C, and D for our first ballot. For second ballot, C, B, D, A, and so on. I'm not going to read all of them to you, but those are our ballots. For convenience sake, we're going to organize those into a table in a little bit later. So here are your essential ingredients for every election. You've got to have voters. You've got to have candidates, which are the electing people, if you're electing people, or choices in case you're wanting non-human alternatives, such as maybe voting for cities, colleges, pizza toppings, etc. So it's not always about electing people, although that's the most common and that's the one we'll spend the most time with. And then for ballots, we have our preference ballot, which is where you rank it in order of preference, and then linear ballots where ties are not allowed. Okay, So to summarize what we saw with our preference ballots, here is what we call a preference schedule. So a preference schedule is kind of our way of summarizing all of those ballots in a single table. And really, if you go back and look at all those ballots, there's only a few ways to rank our results. There was really only 5 different ways that the voters chose to vote. And so here's kind of how those were broken down. So you had 14 people that voted for A as their first choice, B, C, D, all the way down. We had 10 that voted for C for first, and then B, D, A. 8 for D, C, B, A, 4 for B, D, C, A, and 1 person voted C, D, B, A. Okay, so we're going to talk about a couple of properties that are apparent in this election. The first is what's called the transitive property, which says that if a voter prefers A over B and also prefers B over C, then they automatically prefer A over C. To give you an example, maybe looking at this first ballot, if they prefer C over B and they also prefer B over D, then automatically that means that they prefer C over D. Should kind of make sense, but that's just kind of the name of that property. The second is what's called elimination, which says that relative preferences are not affected by the elimination of one or more candidates. So when we're talking about they prefer C over D, if we eliminate person B, then that still holds. The fact that they prefer D over A, if we eliminate B, then that still holds as well. So, in the next section, we're going to return to the business of deciding this outcome of elections in general and of the Math Club election in particular. So, that's all we've got. Pretty short video for us on this first lesson. Again, we'll talk next video about what's called the plurality method and how that's used to choose not only the winner of this math election, but also most of our elections here in the United States. That being said, guys, have a good rest of your time. See you next time.